Hello and welcome to the extension for 10.8. What we're going to do today is work with regression lines. Here are the solutions for 10.8. If you have any questions on those, please see me. Alright, so what we're going to do is work with the graphing calculator. So today just focus on making a list of steps, and you should have a similar list because we did this with linear functions or linear equations. And what we're going to do today is work with exponential and quadratic linear regression lines. Or sorry, regression, not linear regressions, just quadratic regression. So basically line of best fit. So the line that most follows the trend today is called the line of best fit. Some vocab words for you guys. The process of finding the line to model is called linear regression. So we're going to be working with quadratic and exponential today. Using this line to predict inside the data is called interpolation. And if we were to predict values outside of our data, we call that extrapolation. Some vocab words that you guys may not have learned before, so jot those down in your notebooks. And so what I mean by that, so my data goes from 12 up to 25. So if I predict anywhere from 12 to 25, then that would be called interpolation. If it's colder than 12 or warmer than 25, and this is Celsius, so keep in mind that's not like Fahrenheit, that would be extrapolation. So if it's colder than 12, let's say I predict for 30 degrees, how much this must be talking about some kind of cost for like heating or something, or air conditioned, whatever. Okay, let's get to it. So here we have our set of data, and it's talking about organic milk and cream, half and half, stuff like that, from 96 to 2000. Find an exponential model. So what we're going to do is we're going to take our calculator, and we're going to enter the data into our calculator. So we're going to go to, and this is the stuff that you should be writing down. So stat, edit, and if there's anything in here, again, just like last time, do not press delete. If you press delete on list 1, deletes the entire list, so do not do that. Now for 1996, we're just going to call that year 0. For 97, we're going to call that 1. So don't enter 1996, 97, 98. It just makes it more complicated. 98 and 99 and 2000. And this is in millions. Again, you don't need to put in 15.8 million. Just put in 15.8. The units will be in millions. 30.7, 46. And they're going to tell you which type of regression to do. And the reason for that is sometimes linear and quadratics, they look very similar because they both hook up to the right. So they like hook up, and then they make that U shape or that hook shape. So, okay, there we go. We got our list in, and we're gonna go to next page, and we're just gonna make sure that our scatter plot's turned on. So the easiest way to do that is to go to your y equals menu and just turn plot 1 on. That's the easiest way. Just highlight that and then just press graph. You may not see any data there, so what you want to do is do a zoom stat, because we're doing statistics. Zoom stat, and there's your data. Okay, so the next thing we're going to do is we're going to run our regression. So we're going to go to stat again, go to calculate, and we're doing exponential regression. So I got to find that on my list here. Okay, exponential EXP regression. Press enter. Press enter again. It's going to do some stuff there. You're going to write that equation down. 17.51 is A, 1.5 or 1.60 is B. So you're going to write that down, and you're going to graph that. So I went to the y equals menu to graph it. All right, there we go. And press graph and see if that regression line looks pretty good. So far, so good. And yeah, that looks great. So there you go. You may see this r squared and r. Those are basically telling you how the correlation and how closely the data fits to your graph. This is something that's studied more so in high school. So you guys are going to see this r squared and r in high school. And then we just did that. We graphed it. So we put the y equals many. We graphed and compared. What will the sales be for the year 2000? Well, we already had 2000. I think we want to, let's do like 2005, I guess. Let's change that to 2005. Okay. So I started with 96. So what I'm going to do is on my calculator, I'm going to go, you can either plug in 5 into the equation. That might work best. So let's just go to, you can either use the table and scroll down to the right value, or you can plug it into your equation. So this was 96, 97, 98, 99, 2000, 2001, 2002, 3, 4, and 2005. So 1203. And this is in millions. So there you go. So it'll actually be 1,203,000,000 dollars. So that'd be your answer. So that's called extrapolation. That's predicting outside the set of data. And then you can do the same thing for quadratic, and I'm not going to do that. The only thing different is on your calculator, when you're doing your statistics, you would go to calculate, and then you go to quadratic regression. Notice how it's not quartic. That's quartic, so we want quadratic. And you could do the same thing and then repeat it. So that's all I got for you guys today. We'll check out, we could do this as a class, this one here, and just do it as a warm-up problem in class. But like I said, it's the same thing. And we'll be working on this in class. So thank you guys. I will talk to you tomorrow.